UGC Net Electronic Science June 2025 question paper solutions part 3, that is from question number 51 to question number 75. Question number 51, in layout design rule, what should be the minimum width and spacing of metal and diffusion layers? Minimum width is 2 lambda and spacing of metal and diffusion layers is 2 lambda. The correct answer is 4 lambda, option 4. Question number 52. In list 1, low dimensional structures are given. In list 2, density of states versus energy is presented. For quantum dot, discrete energy levels, vertical lines. For statement A, it is 4. Quantum wire, one dimensional structure, it is having sharp peaks. Quantum wire is having quantum wire is a one dimensional structure with sharp peaks. B matches to 3. Quantum well, 2D structure, step like increase. So C 2. Bulk is a 3-dimensional structure, continuous increase. 3-dimensional structure, continuous increase. D matches to 1. A4, B3, C2, D1. Correct answer is option 1. So let us see some more points. Quantum dot is confined in all the 3 dimensions. It is having discrete energy levels, and the energy levels are delta functions. Quantum wire is one dimensional, confinement in 2 dimensions. Density of states has singularities, that is spikes. For quantum well, confined in one dimension, density of states increases in steps. Bulk is a 3-dimensional, there is no confinement, density of states increases smoothly with respect to root E. Next question, spectrum analyzer is a. So let us see some points related to spectrum analyzer. Spectrum analyzer measures the magnitude of signals versus frequency. Therefore, spectrum analyzer is a frequency domain instrument. Spectrum analyzer displays how signal power is distributed across different frequencies. The distribution of power over different frequencies. Unlike oscilloscopes, which operate in time domain, spectrum analyzers are used to analyze the frequency components, making them essential for radio frequencies, audio frequencies, and communication systems. It is a frequency domain instrument. CRO is time domain instrument. CRO is time domain instrument. Question number 54. The transistor count in 8086 microprocessor is. So this 8086 microprocessor announced in 1978. 8086 microprocessor is a 16-bit microprocessor. Similarly, 8088 microprocessor is a 16-bit microprocessor with 8-bit data bus. In 8086, it is having 16-bit data bus. Both this 8086 and 8088 are manufactured by using HMOS, high performance metal oxide semiconductor technology, and both contains 29,000 transistors. About 29,000 transistors. The transistor count in 8086 microprocessor is 29,000. Correct answer is option 3. Question number 55. Which of the following statements are true for optical photoresist? In photolithography, photoresist are classified into two types. One is positive photoresist and the second one is negative photoresist based on how they behave when exposed to light. Positive photoresist becomes more soluble in developer solution when exposed to light, whereas negative photoresist becomes less soluble in a developer solution when exposed to light. Let us see the statements. Statement A, solubility of photoresist changes on exposure to light in developer solution. Statement A is correct. Statement B, the solubility of photoresist does not change when exposure to light in a developer solution. Statement B is incorrect. Statement C, negative photoresist on exposure to light becomes less soluble in developer solution. Statement C is correct. Positive photoresist on exposure to light becomes more soluble. Statement D is correct. Correct answer is option 4, A, C, D only. Question number 56. Frequency can be measured by using. So different bridges are given. Let us see the different bridges and their parameter measurements. First one is Wheatstone bridge. Wheatstone bridge is used for the measurement of unknown resistance with high accuracy. Next is Kelvin bridge for the measurement of very low resistance. Maxwell bridge measurement of inductance, medium Q factor coils. Hay bridge measurement of inductance for high Q factor coils. Anderson bridge precise measurement of self inductance using standard capacitor. Owen bridge used for the measurement of inductance using two capacitors and two resistance. These Maxwell, Hay bridge, Anderson bridge, and Owen bridge are used for the measurement of inductance. Shearing bridge for the measurement of capacitance and dielectric loss. Measurement of capacitance and dielectric loss. Wien bridge measurement of capacitance and frequency. Desarty bridge measurement of capacitance without loss factor. So these three bridges are used for the measurement of frequency. So measurement of capacitance. Shearing bridge, Wien bridge, and Desarty bridge. In the question, the frequency can be measured by using Wien bridge. Correct answer is option 4. Question number 57. 5 different statements are given. We need to choose a correct statement. So let us see. Statement A. A 2 to 1 multiplexer can be used to implement any logic function. Statement A is correct. A 2 is to 1 multiplexer acts as a universal logic component because its select input combined with its two data inputs and a single output allows it to mimic the functionality of any basic logic gate and or not by strategically connecting inputs on the select line to logic 0, logic 1. Here it is not gate. Statement A is correct. Statement B, 3 2 input NAND gates can be used to implement the logic function f is equal to AB plus C. So let us see, f is equal to AB plus C. It can be implemented by using AND gate, one 2 input AND gate and one 2 input OR gate. So this AND OR gate is converted to NAND and logic. Add bubbles or the output of AND gate and the input of OR gate. So like this, represented in 2. So we will get figure 3. So this bubbled OR gate, can be replaced, bubbled input OR gate can be replaced with the NAND gate. So we have NAND gate, again NAND gate. NOT gate can be replaced as when two inputs are tied for a NAND gate, then it acts like a NOT gate. Here it is variable C, variable A, B, and the function F. So here 3 gates are used, 1, 2, 3. 3 2 input NAND gates are required for implementing the function f is equal to AB plus C. Therefore, the statement B is correct statement. Next, static random access memories can retain information even after power supply is switched off. So this RAM is of two types. RAM is of two types. One is SRAM and DRAM. RAM is a volatile memory. Therefore, SRAM is also a volatile memory which cannot retain information. Statement C is incorrect. Read-only memory is a volatile memory. Read-only memory is non-volatile memory. Statement D is incorrect. DRAM is fastest memory. Let us see the comparison of SRAM and DRAM. SRAM stands for static random access memory. DRAM is dynamic random access memories. Transistors are used to store information in SRAM. Capacitors are used to store data in DRAM. SRAM is faster. SRAM is faster than DRAM. DRAM is having high density. So here dynamic RAM is fastest memory. It is incorrect. SRAM is the fastest memory. Therefore correct answer is option 2. Only the statements A and B are correct. Next question. The indirect method of generating a wideband FM signal involves. Let us see this block diagram here. Message signal is given, modulating signal, narrowband frequency modulator converted into narrowband frequency wave. This narrowband frequency modulated wave is again applied to a frequency multiplier. This frequency multiplier is a non-linear device which produces the output signal whose frequency is n times of the input signal frequency, thereby producing wideband frequency modulated signal. Here narrowband FM modulator contains integrator, phase modulator. This is narrowband FM modulator. Integrator, phase modulator producing narrowband FM signal. Here we require baseband signal. Baseband signal is required, integrator is required, phase modulator is required, and then frequency multiplier. Correct sequence is A, B, C, D. First, baseband signal applied to an integrator, narrowband phase modulator generates these three blocks generate narrowband FM signal. This narrowband FM signal is applied to a frequency modulator which produces wideband FM signal. Input is supplied to this narrowband FM signal is given as input to the frequency multiplier which generates wideband FM signal. Correct answer is option 4. In this direct method, voltage controlled oscillator is used. The modulating signal is directly converted to wideband frequency modulated signal. Next question, question number 59. Given A bar is equal to 3y power 4 z square ax cap plus 4x cube z square ay cap plus 3z square y square az cap. Then del dot A is d by dx of a bar into ax cap plus d by dy of a bar into a bar dot dy cap plus d by dz a bar dot az cap. On solving we will get d by dx, only this unit vector, ax cap dot ax cap it is 1, ay cap dot ax cap is 0, 3y power 4 z square plus d by dy of 4x cube plus z square d by dz of 3z square y square. Now there is no x variable here. In this term is 0. There is no y variable here. This term is 0. Then dou by dou z of 3z square y square. its value is 3 y square is constant and dou by dou z of z square is 2z. So correct answer is 6 y square z. Option 2. Question number 60. Arrange the following semiconductors in the order of their use from top layer to bottom layer of multi-junction solar cell. In a multi-junction solar cell, layers are arranged so that top layer has largest band gap and the band gap decreases as it goes to the deeper. So for germanium, band gap energy is 0.67 electron volts. For gallium indium arsenide, it is 1.42 electron volts. For aluminum gallium arsenide, 1.69 electron volts. Gallium indium phosphide, 1.85 electron volts. So this gallium indium phosphide is top layer and germanium is bottom layer, which is having lowest energy band gap. Gallium indium phosphide is C, aluminum gallium arsenide is B, gallium indium arsenide is D, and germanium is A. Therefore, correct sequence of arrangement in a multi-junction solar cell is C, B, D, A. Correct answer is option 1. Question number 61. The ascending order of pin numbers of 8086 microprocessor is here NMI pin number is 17, NMI pin number is 17, INTR 18, INTR is 18, lock is 29, 29, RD bar 32, minimum max bar 33, min max is 33. Ascending order, they have asked for the ascending order, therefore correct answer is A, B, C, D, E. Option 3. Question number 62. Arrange the following in correct sequence of steps for mass fabrication. General sequence of steps for mass fabrication is: first step is wafer preparation, second step oxidation, wafer preparation, oxidation, photolithography, etching, gate formation, source drain formation, interlayer dielectric deposition, metallization, passivation, testing and packaging. In the question they have given wafer preparation, oxidation, photolithography, gate and drain source formation, and then metallization. As per the question, the correct answer is 3. A, C, B, D, E. Question number 63. 5 statements are given. We need to identify the correct statement. If g of t is g of f, then capital G of t is small g of minus f is duality theorem. Statement 1 is correct. The duality property of continuous time Fourier transform is small x of t Fourier transform is capital X of omega. The Fourier transform of capital X of t is 2 pi small x of minus omega in W domain. So that is statement 1 is correct. Statement B, mixer is not a basic element of superheterodyne AM receiver. Let us see the block diagram of superheterodyne receiver. This block diagram initially it consists of receiving antenna followed by RF stage, mixer, Local oscillator is connected to the mixer, IF amplifier, demodulator, audio amplifier, and then power amplifier. Final stage is loudspeaker. Statement B is incorrect. Mixer is a basic element of super heterodyne receiver. Statement C. The power spectral density of wide sense stationary random process is always negative. So let us see definition of wide sense stationary process. A random process x of t is said to be wide sense stationary if it satisfies the condition that mean is constant. Rx of t1 comma t2 is a function of time difference. Autocorrelation depends on time difference, mean is constant, and power spectral density is real and negative. For wide sense stationary process, power spectral density is real and non-negative, and it is having even symmetry, and the total power is represented as Rx of 0 is equal to minus infinity to infinity Sx of f df. Statement C is incorrect. Power spectral density of wide sense stationary random process is real and non-negative. Statement D. Typical radio frequency carrier range of FM is. Let us see frequency modulation specifications. FM specifications. Carrier frequency range is 88 MHz to 108 MHz. Bandwidth 200 kHz. Modulation index 5. Frequency deviation 75 kHz. Message signal frequency 15 kHz. Intermediate signal frequency is 10.7 MHz. Similarly, AM specifications are carrier frequencies from 535 kHz to 1605 kHz, or it can be written as 0.535 MHz to 1.605 MHz. Bandwidth is 10 kHz. Modulation index mu1. Message signal frequency is 5 kHz. Intermediate signal frequency is 455 kHz. Statement carrier frequency is 88 MHz to 108 MHz. Statement D is incorrect because they have given gigahertz. Typical RF carrier range for AM is 0.535 to 1.605 MHz. Statement E is correct. Statement A and E are correct. Correct answer is option 4. Next question. Flash ADC or parallel comparator type ADC or simultaneous type ADC, which is the fastest analog to digital converter. So A matches to 4. Successive approximation type ADC. This successive approximation type ADC uses binary search algorithm with a digital to analog converter and comparator to approximate the input voltage step by step, and it is having constant conversion time. Successive approximation ADC is having constant conversion time. It is independent of magnitude of the input signal. Dual slope ADC. This dual slope ADC is the slowest ADC, and accuracy, it is having very good accuracy in measurement. Hence it is used in measuring devices. So C matches to 3, used in measuring devices. Sigma delta ADC. Sigma delta ADC uses oversampling plus noise shaping to achieve high resolution. It is using 1 bit quantization. The quantizer outputs is having only 2 possible levels. Sigma delta ADC is 1 bit quantization. Therefore, A4, B1, C3, D2. Correct answer option 4. Question number 65. The op amp with open loop gain of 100 dB has a unity gain bandwidth of 1 GHz. Unity gain bandwidth is 1 GHz, that is 10 power 9. What is the bandwidth of this op amp assuming it a single pole system? Gain is also given. Gain is 100 dB. So convert this gain into normal values, dB into normal values. 20 log gain base 10 is 100 So from this, gain is 10 power 5. Gain bandwidth product is, open loop gain is 10 power 5. Gain into bandwidth is 10 power 9. The gain value is 10 power 5. So from this, bandwidth is 10 power 4, that is 10 kilohertz. Correct answer is option 2. Question number 66. Superposition theorem depends on principle of homogeneity and the principle of linearity. Principle of linearity and principle of homogeneity. Principle of linearity states that the total response to a multiple input is sum of individual responses to, and principle of homogeneity or scaling property states that if input is multiplied by a constant, then output is also multiplied by the same constant. Significance of RH criterion is stability check without root solving. This RH criteria is used to checking the stability without solving the roots. It tells whether the system is stable without calculating the actual roots of a characteristic equation. To calculate the number of right hand side plane poles, Z parameters are open circuit parameters or impedance parameters. Y parameters are short circuit parameters or admittance parameters. The superposition theorem is principle of linearity, principle of homogeneity. A2. RH criterion is to find out the stability of a system. Open circuit parameters for Z parameters. Short circuit parameters are Y parameters. For correct answer is A2, B3, C1, D4. Option 2. Next question. Question number 67. What is the value of output voltage V0 in the given circuit? Assume op amp to be ideal and the MOSFET operating in the saturation region. So given op amp is ideal, therefore voltage at inverting terminal and the voltage at the non-inverting terminal should be equal. So V given here, V plus is voltage at the non-inverting terminal is 2 volts. Based on this ideal op amp, the voltage at inverting terminal should be also 2 volts. Then we need to find the current through 1 kilo ohm resistor, current through 4 kilo ohm resistor. So current through, first we will find current through the 4 kilo ohm resistor, that is 3 volts minus 2 volts by 4 kilo ohm, 1 by 4 kilo ohm, 0.25 milliampere. The same 0.25 milliampere current flows down through the MOSFET into the 1 kilo ohm resistor. Therefore, current in 1 kilo ohm resistor is same current 0.25 milliamperes. The output voltage V0 is 0.25 milliampere into 1 kilo ohm. Its value is 0.25 volts. Correct answer is option 1. Question number 68. Which of the following statements are true? Statement A. The frequency of output waveform of a full wave bridge rectifier is twice of the input waveform. Here frequency for half wave rectifier is same as input frequency. For full wave rectifier it is twice of the input frequency. Statement A is correct. Frequency of output waveform of half wave rectifier is twice of the input waveform. It is not twice. Output and input frequency are same. Statement B is incorrect. Frequency of output waveform of a full wave bridge rectifier is same as input waveform. Statement C is incorrect. Frequency of output waveform of half wave rectifier is same as input. Statement D is correct. Statement E, the DC level at the output of half wave rectifier is same as full wave bridge rectifier. Statement E is also incorrect. DC voltage level is VDC is equal to Vm by pi in case of half wave rectifier. DC voltage level is Vm by pi for half wave rectifier. For full wave rectifier it is 2 Vm by pi. Correct answer is option 4. A and D statements are correct. Question number 69. The ohmic resistance of JFET with VP is 4 volts and IDSS is 10 milliamperes. Ohmic resistance is R naught is equal to 4 by 10 milli. It is 0.4 kilo or 400 ohms. Correct answer is option 4. Question number 70. From the thermodynamic principles, the concentration as a function of temperature has the following relation. From thermodynamics and semiconductor physics, the temperature dependence of a process governed by the activation energy EA follows a Arrhenius relation, that is ND is equal to A exponential minus of EA by KT, where ND is concentration, A is pre-exponential constant, EA is activation energy, K is Boltzmann constant, T is the absolute temperature in Kelvin. Correct answer is option 1. This shows that as temperature increases, exponential term increases, concentration increases with temperature. Let us see some more formulas. The equation for electrons in conduction band is N is equal to Nc e power minus of Ec minus Ef by Kt, and equation for holes in valency band is P is equal to Nv into e power minus of Ef minus Ev by Kt. Next question. Minor. This minor likely refers to a spectrum analyzer which is used in signal analysis. Therefore, A matches to 3. Gating error. Gating errors are associated with frequency measurement. Gating error is associated with the frequency measurement. B 1. QRS wave. QRS complex is a key part of ECG, representing ventricular depolarization. QRS is related to ECG. C 2. C-shaped bourdon is a mechanical device. It's a mechanical device used in pressure gauges. This C-shaped bourdon tube. D matches to 4. A3, B1, C2, D4. Correct answer is option 4. Question number 72. In 5 ammeters, the full scale deflection current is 1 milliampere. Internal resistance and shunt resistance values are given below. Arrange the ammeters in ascending order of their current ranges. Current range I is equal to Im into 1 plus Rm by Rsh. So let us calculate for option A. I is equal to Im 1 plus Rm by Rsh 10 power minus 3 1 plus 10 by 0.17. Its value is 59.82 milliamperes. For B it is 1.001 ampere. For C it is 79.95 ampere. For D it is 50.08 ampere. For E it is 100.01 milliampere. In the given options, D is lowest and B is having highest value. So D, first value is D, followed by A 59 milliamperes, and then C, E, B. Therefore correct answer is D, A, C, E, B. In the given options, option 4 is partially correct. D is having lowest and B is having the highest. Here, strictly speaking, none of the option is correct. Question number 73. Strain gauge is a dash type of transducer. So we will see different types of transducer first. It is classified based on the five different types on the basis of transduction, primary and secondary transducer, active and passive transducer, analog and digital transducers, transducers and inverse transducers. Based on the transduction, transistors are classified into three types: resistive type transducer, capacitive type transducer, and inductive type transducers. Different resistive type transducers are potentiometer, strain gauge, thermistor, RTD, photoresistor, hot wire anemometer, resistive hygrometer. This strain gauge is a resistive type transducer. Correct answer is option 1. Let us see different types of capacitive type transducers: parallel capacitive, parallel plate capacitive displacement sensor, capacitive pressure sensor, capacitive microphone, capacitive liquid level sensor, capacitive proximity sensor, capacitive humidity sensor. And different types of inductive type transducers are LVDT, linear variable differential transformer, RVDT, rotatory variable differential transformer, reluctance type inductive sensor, eddy current sensor, variable reluctance pressure transducer, synchro or resolver, inductive proximity switch. These are the different inductive type transducers. In the question, strain gauge belongs to resistive type transducer. Question number 74. In the given circuit, the open loop gain of op amp is 15 volts. What is the closed loop gain of the circuit? So given op amp is an non-inverting configuration and open loop gain is 15, very low value. Open loop gain is 15 and the input resistance given here is 10 kilo ohm. Feedback resistance is 20 kilo ohm. Input resistance, feedback resistance. Input voltage is Vi, output voltage is V0. For non-inverting amplifier with finite open loop gain A, the closed loop gain is ACL is equal to A by 1 plus A beta. So A value is 15 divided by 1 plus 15 into beta value. Here beta is equal to Rn by input resistance by Rn plus feedback resistance Rf, that is 10 by 10 plus 20. Now the beta value is 1 by 3. Substitute 1 by 3 in the closed loop expression. 15 divided by 1 plus 15 into 1 by 3. Its value is 5 by 2, 15 by 6, 5 by 2, 3 5s are 3 2s are. The closed loop gain is 2.5 volts. Correct answer is option 3. Question number 75. How many 1 to 4 demultiplexers are required to implement 1 to 256 demultiplexer? So we know that decoder, encoder, multiplexer, demultiplexer are combinational logic circuits. For demultiplexer, number of inputs are 1 and number of outputs are 2 power n with having n selection lines. We need to implement 1 to 256 demultiplexer with the help of 1 to 4 demultiplexer. That is 256 by 4, it is 64, 64 by 4, 16, 16 by 4, it is 4, 4 by 4, it is 1. The total number of demultiplexers required is 64 plus 16 plus 4 plus 1. Its value is 85. 85, 1 is to 4 demultiplexers are required to implement 1 to 256 demultiplexer. Correct answer is option 4. Let us see some more points here related to multiplexer. Multiplexer is a Multiplexer are data selector logic circuits that accepts several data inputs and allows only one of them at a time to go through the output. The routing of desired data input to the output is controlled by the selection lines.